More people are paying attention to crypto right now than ever before, so it's important to get your information from the sources you trust. That's why I want to give a big thanks to Bitwise for sponsoring today's episode. Bitwise manages over $10 billion across more than 30 crypto strategies, and they've been doing this since 2017. But here's what really sets them apart. They give back too. Bitwise actually donates part of the profits from its Bitcoin and Ethereum investments to open source developers, the people building and maintaining the networks that we rely on. So when you work with Bitwise, you're not just getting professional crypto exposure, you're helping fund the future of crypto itself. Check them out at bitwiseinvestments.com or email james@bitwiseinvestments.com and tell them Raoul sent you. Thanks. Let's get some facts. 37% of you aren't subscribed to this channel. That's almost 4 out of 10 just freeloading the alpha. So come on, hit subscribe and I promise to keep leveling up the show with the best guests and the juiciest insight. Go on, do it now. Hi, I'm Raoul Pal and welcome to my show, The Journeyman. That journeyman is that journey to the nexus of understanding between macro, crypto, and the exponential age of technology. The exponential age is my whole thesis around how we're going to see this kind of web of new technologies interacting with each other and changing everything for us, how economies work, how humanity works, everything. And I'm so lucky to have this opportunity in the Journeyman where I'm not confined by having just macro conversations, crypto conversations, tech conversations, but just to talk to the most brilliant and interesting people in the world that operate somewhere within this group of ideas. And we've had some wild conversations over the course of the year with all sorts of interesting people. And this conversation that I'm going to have today is another one that will make your brain hurt and make you understand how disruptive what is happening is. And Lalitesh comes from the background of building Google Maps. And how he did that, the story alone is an extraordinary story. How he used crowdsourced network to create this sort of intelligent platform that allowed then others to build on top of it in ways that he could never imagine. And he used this idea to build something even bigger, Indihood. And I think you guys are going to see that where the world is going, where AI meets technology, meets the internet, meets humanity, and meets the, what we call the global south, the global unbanked, the people who don't have the opportunities, and how that can all be changed. The scale of his ambition is something I've actually never come across before in person. You see people like Elon Musk, but Lalitesh is doing something wild. So I think you're going to enjoy this conversation. So get yourself a drink, cup of coffee, and enjoy. Join me, Raoul Pal, as I go on a journey of discovery through the macro, crypto, and exponential age landscapes. In The Journeyman, I talk to the smartest people in the world so we can all become smarter together. Lalitesh, fantastic to get you on Real Vision.
Real pleasure, Raoul. Thank you for having me.
Look, I'm really excited about this conversation because it's going to go in many directions, but it's really all about the future. But before we get into the future, let's go back into the past. Let's hear a little bit about your journey to where you are today, because it's a phenomenal, interesting journey.
Well, the short introduction of mine is I'm an engineer and remain so to today's date. And learned a bunch of crafts from aerospace to mechanical engineering to computer science to robotics. And when I exited grad school, did a startup and knew how to build technology, but did not understand the difference between technology and product. So crashed and burned. And fortunately, Larry and Sergey liked us. We did a fire sale to Google. It was happened to be.
How did they even get aware of it? How did you manage to?
We had an advisor who was one of their vice presidents of engineering, who joined them later. And he introduced us. And Larry said, I like you guys. I like the technology. So we did a fire sale. It happened to be their first acquisition. Google didn't know how to acquire companies in those days.
Really? What was that business?
We were building a robotic infrastructure. We built it from 98 to 2002 to make programming robots much easier.
Okay. And so that was a very unique departure for them to start thinking about robotics when at the time they were a web company.
Yeah, but I mean, both Larry and Sergey loved robotics, and they also mapped that something that could handle large numbers of sensor events, is no different than the internet, because the internet is actually handling large amounts of events coming into the data center. So that was the mapping that they did.
So then talk me through your career at Google. What did you do then?
So I spent a year building, my first assignment given to me by Eric was to build all of Google's internal systems. So I spent a year doing that. Because Eric did not want ERP capture. He wanted Google to be self-sufficient, more importantly, agile, and have technology that worked for them, because Google thought about everything differently, and they still do. So I spent a year doing that, and somewhere along the way, I got together with 3 other Indian engineers, and we wrote a white paper saying that if Google is serious about organizing all the world's information and making it universally accessible, universal underline, it's not going to happen sitting in Mountain View. You have to have an engineering office in the part of the world that looks different than Mountain View. And India happened to be a good fit because India looks very differently than the rest of the United States. And India also has a bunch of engineers. So before we proposed it, so Larry and Sergey found this proposal on the intranet before we formally proposed it. And in one meeting, Wayne, who was the vice president of engineering in those days, came to the room and said, it's been approved. And we said, we didn't propose. He said, no, but it's been approved. So we all got shipped on a plane to find an office, and it turned out to be Bangalore. And me and Krishna Bharat, the guy who created Google News, moved to Bangalore in 2004. And when I moved to Bangalore, Eric gave me a single assignment. He said, I want you to imagine a product that is inspired by India, but useful for the whole world. And the first thing that struck me when I came to India, and there was a book by Hernando de Soto in the back of my mind when it struck me, is that there were no maps. And it was very, very hard to find directions, to the point where your car would stop 3 times along the way to anywhere, and you would ask, how do you get there? How do you get there? Eventually you get there, and somehow.
Because back then the roads weren't great in India either.
No, and they were being rapidly built. And so I said, well, Google is in the business of making information accessible and useful. So I talked to my counterparts. I knew somebody in Yahoo in India. I knew somebody in Microsoft India. I talked to them saying, hey, maybe we can gang together and license maps of India and roll out maps for India. They said, yeah, that sounds good. Then I went to look for online maps that you could get from the map providers in those days, TeleAtlas, Snaptech, and realized they don't have India maps. And the Survey of India does not have India maps. So nobody actually had the maps. And then when I looked wider, I realized actually most of the world is not mapped. The aha moment was when the business development guy who was procuring maps for the US and other places, I said, can you send me the best maps available in these countries? And he sent me the best maps for Kenya. And it had one highway running through the entire country. And then I realized this is not going to work. And the reason why was it used to take, in those days, using GPS trucks. They would fly down a GPS truck to any country that needed mapping, and they would drive it around, and they would charge $10 to $15 per kilometer. And there was no ROI at $10 to $15 per kilometer, right? Especially because in a country like India, 3 million kilometers, $45 million, you have to redo it every 2 or 3 years because all the roads are being redone, right? And so I was standing there in the Google office, and they were like, we were on the 4th floor, and a bunch of people walking on the road. And it struck me that, all these people around, and the interesting thing about India is when you ask somebody for help, they help. Right? When you stop somebody and say, hey, I'm lost, can you help me? They would help. I'm like, well, these are 4,000 helpful people. And if you gave them the ability to map, if just one of them mapped that road, and this was replicated for every road in the world would be mapped. Right? And that was the birth of this thing called Google Mapmaker. We called it GeoWiki in the early days. So this was 2004. And we started writing code in about 2005, and 2008 we launched to 17 countries. Interestingly, India was not the first country we launched to. It was Pakistan and 15 Southeast Asian countries. And not surprising to me, because people in this part of the world help each other, right? Far more than people realize. And actually, people in every part of the world are altruistic, more altruistic than people give them credit for. So people started mapping, and these countries got mapped crazy fast. Within a year, most of the country was mapped, and we launched India into.
So how did the people do the mapping? They drove around and just
no. We just, in those days, in those days it was all a web interface, right? Mobile maps, mobile internet was not a thing. This was 2005, right? 2008. So we gave them a web interface with satellite imagery, and people drew the roads, they drew the parks, they drew the lakes, they labeled them, they even added town restrictions, everything, right? So we created a full editor which people could use. And I backed it with computational geometry so that even when they were doing a sketch, it would actually precisely fit to the road and things like that. And then the harder part was actually trust, right? Because people would draw garbage, right? So we built a trust system which figured out who to trust, when to trust them, where to trust them for. And with about a team of 50 people curating from the Google Hyderabad office, we had 189 countries mapped from there. So that's how that happened.
And when we talked previous to this, you mentioned about how you incentivize people to do it. I thought it was really clever.
Yeah. So the initial wave of mappers were people who were so, altruistic. They really wanted their community to be mapped. They wanted their city to be mapped and so on. They didn't want any reward. To them, the map was the reward. So in the early days, all they would ask us is, hey, we are mapping on Mapmaker. When is this map going to show up on Google Maps, right? So we worked very hard to get maps from Mapmaker to Google Maps faster and faster. Initially, it took 3 months. Eventually, it came down to 9 seconds, right? Anything you drew made it to maps in 9 seconds. But we realized that the larger population wants a little bit more. So what we did is we said, look, there are mappers who are the best mappers on a country scale, on a global scale, and so on. And giving credit to 5 people will not do justice to all the people who are toiling away for the neighborhoods. So we said, if you take every map view, right, at every zoom level, if you could compute and display the top 3 mappers in that viewport, people would have satisfaction that they mapped this part of their world, right? So we did that. It was a bunch of interesting distributed computing. One of our smarter engineers figured it out, and when that went live, people loved it, right? People would even if you drew the 4 houses in your neighborhood and the 1 lane in your neighborhood, you zoom way down, your name would appear, right? So.
What you actually built was a decentralized coordination layer for large amounts of people. Really fascinating stuff, because the internet had just started enabling stuff like this. This was not really possible beforehand.
Yeah, and this was the first, I think, crowdsourcing property in the world where everybody could edit and everybody could moderate. We didn't have badge moderators. On day one, everybody could moderate, and based on the trust that the trust system computed, your moderation would go live or not. So we just allowed everybody to do everything. So that's how this distributed governance came about.
Super clever. So where did it go from there? So that we're 2008 now. So you're at Google and you've now built an extraordinary thing which just changes the world, which is a bizarre thing to think about for you, but that's what happened, right?
Yeah, it took 3 years, 2008 to 2011, I think early 2012. The entire, what is now known as the Global South was mapped. And it turned out that the Global North, if you will, had good maps, but not amazing maps. There were still gaps in those maps. Interestingly, when we started using Mapmaker, Sand Hill Road in Palo Alto was not mapped. It was insane, right? So we said even the United States needs it. Of course, we were very, very cautious, rightly so, in launching it in the US. But the culmination was we launched it in the US in late 2012, and then we started launching it across Europe. So it took until 2014 until the mission was complete, right? And somewhere along the way, I stepped out. 2012, once I launched US, my job was done, right? And they were great leaders. So I left that behind, studied emerging markets. I was one of the 2 engineering leaders of emerging markets engineering for Google, studied emerging markets quite a bit. And I realized that there was something else that was broken. And Google was not the place to fix it, even though I tried. I had my last conversation inside Google, interestingly, was with Sundar Pichai. He was not the CEO those days, but we saw eye to eye on a lot of things. He was very supportive, and he kind of agreed with the mission I was on. So I left, and here I am.
So what was the mission you went on, and why?
So when
because there's many layers to this. One is the outcomes, but also what you're building. I mean, the whole thing is, it's complex but really interesting. Yeah. So, when you sit down with Sundar, what was your mission and vision that you said to him?
Yeah, the mission I said is, and he agreed with it. He actually even, he gave me credit for it later, but he kept the project around. I said, look, I had this project called the Next Billion, right? And I left it behind as, something that Sundar took over. I mean, I had so much trust in the guy when he took over. I said something good will happen. The notion was that the world does not work for all 8 billion of us, right? The world works for about 2 to 3 billion of us. The rest of them struggle, right? And this is not new. This has been there pretty much since, early civilization. The world has never really worked for everybody because there is this feudal pyramid of exploitation that was built. It is still there in many shapes and forms. I mean, the simple example is this nice shirt I'm wearing that my wife bought for me, right? And I'm pretty much sure that the lady who probably weaved it in some factory in Bangladesh or Vietnam or India does not have a great life. And I saw this article recently, about a month ago, that the global warming combined with the factory heat in the summers is causing women to, faint and lay down in factories while they are, weaving shirts for us, right? And they don't get a good living wage, right? And, there's nothing, I mean, we can get upset about it, but the reality is this has always been the case, right? And the only solve, and I saw that when, I saw that during the Mapmaker days when, there was this lady, Julia, who took Mapmaker and started, and she built a layer on top of it to map atrocities against women in Kenya. And that was Usha Hidi. And then it turns out that, atrocities and oppression against women is not Kenya specific, it is worldwide. So that became a worldwide phenomenon. And George Clooney used Mapmaker to map wherever violence was happening when South Sudan succeeded from North Sudan, right? And he said, what happened in Rwanda will never happen again. People will never be able to say, I didn't know violence was happening, because that was the excuse the congressional committees gave when they said, we didn't know this was happening, right? So, and then, these were the more, PR centric stories, but there were 20, 30, 40 people who showed up and said, I want to map, coastlines, I want to create a map for livelihoods and so on. And I realized that not only, the solve for the world is digital as a layer. If you add a digital layer that has the kind of distributed governance and ownership of the community, it is possible that the world does not work for all 8 billion will actually start working, right?
Because people can coordinate, and you'd learned that. If they have a commonality of interest, they can coordinate, and if you give them a platform like the maps, they use it in all sorts of ways you never expected.
It's
not driving to A to B, it's actually using the platform for other things, which is super fascinating.
Yeah, so to give you 2 examples, when we built Mapmaker, what happened is the UN came after us and said, hey, we need these maps for disaster. And we said, what do you mean by disaster? They said, the problem when disasters happen is you don't have maps. If you already have maps, we can do much better aid and relief. And they sent this letter back, which was very, very dear to me. In 2010, when Pakistan got flooded, 20% of the country, 10% of people were displaced. They sent a letter saying of the 4.7 million people, they reached aid to about 800,000 people, and 250,000 people that they rescued would not have been but for the maps of Mapmaker, right? And then they did this about 200 countries, right? And we had no idea when we started that this was going to be used for disasters. And we had no idea that, NGOs would have ambulances find people in distress in time when they were not able to find them before, right? And to take a non-map example, I'll give you another example. If you take, farmers in the global south, who all of them struggle, and a big cause of global warming is because they struggle for livelihoods, they do things that are not good for the soil, and they do things that are not good for the environment. And interestingly, so do farmers in Iowa. Iowa State was one of the places I went to, and when I talked to my friends in Iowa, they say the same thing is happening, right? Iowa has cancer clusters because of what they have done to their ground, and so does Punjab. I mean, this is a global thing. And the interesting thing is, and this is food that sustains us, right? And that food actually makes a lot of money. So what if, thousands of farmers, coordinated together, and they jumped 2 levels in the supply chain. They started owning the supply chain that, they are the source of. If you do the math, and, I verified this with some experts in Gates Foundation, they said if you did that, farmers would thrive. Their incomes would explode, not like 20-30%, but 3-fold, 5-fold, 10-fold. So the answer is, if you take, if you bring digital the right way, like you said, bringing governance and ownership to communities, the world might look very different. The problem was a computer science problem, which is building such population scale platforms is so difficult, takes so much expense and so many engineers, that it is not feasible to build these thousands of bespoke platforms that communities own. And that was the reason, what I'm doing, what I'm doing today, which is this building this, instead of building one platform at a time. And I realized, I was in my late 40s when I left Google, 2014, now in my mid 50s. And I realized that the best I could do is build 2 or 3 platforms before I hung up my boots. And that's not going to solve any problem. So let's try to swing for the fences and see if we can disrupt how platforms themselves are built. And let's see if we can crash the cost of building them and the effort of building them by a factor of 100. And also simultaneously make them living and breathing, where responding to the users in the community, the platforms evolve themselves, right? And if we can solve those 2 problems, we will have the kind of positive disruption that we would want to see. So that was the idea behind Indihood, the current journey I'm on.
And so what have you built? Let's talk us through what you've built, because again, it's unique technology and it's a very different vision than other people have had.
So I can talk to you about the technology we have built, and I can talk to you about the impact it is potentially going to have.
Yeah, let's start with the technology, because it's very interesting.
So we brought 3 technologies together. One of them, of course, is this crowdsourcing, deeply traceable, observable, controllable fabric of building data systems, right? But that is the underlying substrate that allows flexible platforms to be built. The problem with building platforms is the large amounts of code that you have to write, right? And unless we crash the amount of code that is written, this won't work. So we built essentially a declarative distributed system, which allows a specification to be taken, a well-written technical specification to be taken and turned into, software without writing the code in the middle, right? And the early data we have is showing us that we are reducing the amount of code that you need to write by a factor of 30, right? Instead of, for example, writing
How?
So you write the specification, you don't write the code, and the third element that works on this declarative specification and the declarative technology we have built is something called the Alan Newell blackboard metaphor, right? Alan Newell was one of the founders of modern AI, right? And this was in the 70s when AI was being invented. And around the same time that Hinton came up with neural nets, Newell came up with the blackboard metaphor. And the blackboard metaphor actually turns out to be harder to compute than neural nets. So it has actually never been brought to life fully generally until now. So that is the other underlying infrastructure. And what the blackboard means is, if you have this declarative specification, include the schema, the logic, the workflow, and so on and so forth, defined, you have we create agents. You'll create an agent which understands data stores. You'll create an agent which understands front end. You'll create an agent that understands how user interfaces are built. You create an agent that understands how to create a search index. So you have like these 10 agents, and they create all the building blocks which constitute an information system. So these agents go to work on this declarative platform, and they generate their part of the entire platform, and together the platform comes to life. The interesting thing about the math behind the blackboard metaphor is the agents are aware of the blackboard, but the agents are not aware of each other. So it's an emergent phenomenon, right? So
explain.
So imagine you have a blackboard, right? And there are 10 people writing on it, and they're coordinating by, and you can't see the other 9 people writing on it, but all you see is what is being written on the blackboard.
Okay.
So it is possible, and that's what this
sounds quite quantum. It sounds quite quantum.
Yeah. In many ways, it has the same idea. So it is by observing what my peers are doing on the blackboard, I can configure myself so that the thing I'm doing makes sense, and others are doing the same thing. So it's an emergent phenomenon where all the 10 agents working together on a single blackboard can create a whole canvas that works.
So they end up becoming self-coordinating because of this one source of truth of which everybody's working on, and therefore they self-coordinate. And
you put a whole bunch of constraints and layers on this. And one of the things we had to crack is declarative systems. I mean, we had to crack 2 computer science problems. Declarative systems are notoriously, slow and notoriously expensive. And this is well known. So that's why they never got out of the lab, even though the idea has been around since 70s. So we had to crack that. And interestingly, now we are actually, computationally more efficient than a handwritten system. So that switch happened. And the second thing is declarative generative systems have a verifiability problem, right? You can see this even in the Gen AI generated stuff. How do you verify? How do you know it works, right? So one of the layers that we cracked was the ability to self-generate tests that are correct. So today, the machine we have built, as you're using it, it is writing tests in the background. So every day that you use it, thousands of tests are being written. So you have this cloud of millions of tests which are there. So you make any change to the platform, that change has to pass all of this tests before it goes live. So your platform, as it is used, becomes more and more stable over time.
And this is why it's so efficient at writing code, because it self-tests as it goes.
Yes.
At scale.
And this was, by the way, to be very candid, this idea is not new. In the 90s, there was a breakthrough which allowed modern processors to happen. The largest processor that was built, I think, by Intel, which was hand designed, was a 1 million gate processor, right? After that, VHDL came along, Verilog and so on came along, and the breakthrough there was you wrote the specification and you wrote the simulators, and the entire layout of the chip was verified by this verification system that allows modern processors to happen. So we are doing to software building what was done to chip design in the 90s.
Out of interest, why didn't you use a neural network to do this? Why did you go to the blackboard method? Something that was computationally hard and hadn't progressed so long. What made you make that decision?
Rigor. Let me explain what I meant by that. When I built Mapmaker, the best crowdsourcing technology in those days was Wikipedia, right? And we did an eval of Wikipedia, and we found that roughly 60 to 80% of the text in Wikipedia was right. About 20 to 30% was incorrect, right? And 60% of the links, it's now much better than those days. 60% of the links were spam because people couldn't see the links, right? But the interesting thing about map, if you, from a computer science point of view, a map is a grid, like it's a graph. In computer science terms, it's a graph. And if you take a graph and you take 2 or 3% of the links in the graph and you mess with it, your entire driving directions in the city goes haywire, right? So maps is very, very sensitive to errors. And so we had to get it down to 3 sigma plus quality, right? And as you know, neural net generated stuff in then and even now is approximate. It's very good, but it is approximate, right? you do great if it crosses 90%, you celebrate if it crosses 95%. And it rarely crosses 97%. And even if it does, that 3%, when it is wrong, it doesn't know it's wrong. So the more important, see, it's actually less important what percentage it gets right. It's more important that when it is wrong, it knows it's wrong. When it's right, it knows it's right. We call it the L1 error, right? So the L1 error in a system that is mission critical, right? Maps is mission critical. We use this technology to build a bank, right? A regulated bank. Bank is mission critical. You cannot have errors more than 0.3%, 0.4%, right? So that's the reason why we moved to this metaphor, because this is more deterministic and it has certainty built into it. And it is possible to verify the system. So,
and then so you've used this AI methodology. You've built this platform that collapses the amount of code that you need, the speed. Yeah. It's a coordination layer of agents that are doing the work alongside humans. So
yes, of course.
So the agent can be a human, or the agent can be an agent, an AI agent. Yes. Working in this decentralized platform.
Which is living and breathing.
Yeah. And it adapts, it tests, it learns, it iterates. So it really is a living, breathing thing.
Yeah.
What was your vision of what should be built on it? What is it? First, before we talk about the bank, but what is this thing? What is the point of it?
The point of this is, I mean, the dream of this is that information systems that enterprises and communities use to work, transact, and play, right? It is designed to do all of it, right? And every use case that I talked through initially would fit into this, right? So the dream is that people would build their own, and we're not there yet, right? We are not hit general availability. So when we hit general availability, my guess is 3 years from now, we will open it up to the world and people will build platforms that they want.
So this is a coordination layer to the internet, of which it enables the rapid building of things.
A coordination layer for distributed Freemasons to build their own universe. Yeah.
Yeah. Yeah. Much like, let's say, the games people have built to allow people to build 3D metaverses, essentially, in whatever format you want, to turn it into games, whatever you want.
Yeah.
So, a quick break in your regular programming. If you're serious about your future, grab my free report called Prepare for 2030. I think you've got 5 years to make as much money as possible, and this guide will help you navigate what's coming. The link is in the description. Download it now. And so, what is the first use case that you're building out for it?
So the first use case we built was, like I said, I was getting up in the age. So I said, I want to know if this is going to work. And the only way you know it's going to work is you take the hardest use case somebody is willing to let you experiment with. So we took on a bank, right?
In India.
In India.
Which makes it 17 times more complicated. I've been trying to close my Indian bank account for 11 years and I can't close it. So that's how complicated Indian banking is.
Indian banking is probably the most regulated in the world, right behind the US. The two most regulated environments in banking are India and US, and India is far more so. For good reason, because there's a lot of fraud that would happen otherwise.
Yeah, and India has a love of bureaucracy as well. Even though they built the entire fintech layer via Aadhaar and UPI and all of that, they still have this fabulous Indian bureaucracy that the British left behind.
Yeah, we can't keep blaming the British. Not time to dismantle that. Exactly, but yeah. So around 2014, to understand, the global South and understand the world in reality, one of my mentors introduced me to Mr. Ratan Tata, and we got along really well. He said, "How can I help?" I said, "I want to understand India." He said, "I'll do your trade. You be my CTO for Tata Trust, this charitable organization that family has been running for 150 years, which actually has 66% of ownership of all the Tata Group companies. You be the CTO in residence, and I will teach you everything I know about India." Right? And in the journey, one day he came to me and said, look, one of the common things that he has found in the 750 communities he's serving is people are very poorly financed. They don't have access to finance, which you know very well. And he said, can you help me, imagine what this would be like? So I wrote this white paper. The last chapter of it was tokenization, not surprisingly, called 11-Minute Loan. And he liked it. And he then showed it to another person who's been building Digital India, Mr. Nandan Nilekani, right? And Nandan and I knew each other from the Aadhaar days and so on. And Nandan looked at it and said, okay, this crazy bugger. Okay. And both of them liked that idea and they funded it. And Nandan said, I will only back it if you build this for me. He turned to me and said, if you build this for me. And I said, well, I'll build it with this new technology I'm creating. He said, I will accept it as long as you stay with it and you don't, this is the only thing you do for the first 5 years until it's stable. So we had our first use case. So long story short, it's been about 6 years now. And that system, that platform, it's called Avanti Finance, right? Amazing company. I think it'll be one of India's largest rural banks 10 years from now. They are doing well. I mean, there are ups and downs in banking, but they're doing well. They've issued 1 million loans on the platform. And their efficiencies are off the charts. They're like, 250, 300 basis points better than their peers.
So how did this just step a bridge between the technology and the bank? Now there's 1 million loans. How did the technology enable this? What was so unique about how this was built?
Well, there are many things. I mean, we could spend an hour doing it, but I'll give you one example. Not surprisingly, it was about the living, breathing nature of the platform that we were able to build using this. So one of the things we did was we built a loan management system, LMS, from scratch, which is highly flexible, hyper flexible. And on top of that, we built something called a product maker. So usually banks have loan products, lending products, and they have savings products. And you go and pick one of them and you use it, right? And a great bank will have something like 40 of them, 50 of them. We said we have no idea what products will serve these users well because their livelihoods don't make any sense to us. We don't know what they do and what they need. So we will create a product markup language and we'll create a product maker, right? And the way Avanti works is Avanti does not do its own field operations. Avanti has 80 partners on the ground. And each partner operates this platform we have built on top of our platform generator in their own way. Because we gave it something like 250 configuration knobs using which they tweak how this platform works for each of those 80 communities spread across India. So by the way, this Avanti is now across India and 4,000 pin codes. Pin codes is like zip codes. And that's 1/4 of India's landmass, right? What they have done is every time users came to them for livelihoods, the interesting thing about people who are underserved global south is most livelihoods don't have the predictable monthly paycheck pattern that most of us are used to. Their cash flows are non-linear and they ebb and flow. The users know what they are, we don't know what they are. So what we noticed is the community started designing loan products where the repayment profile of that loan product was conformed closely to the cash flow needs of that community, right? The cash flow of that, community.
Therefore meeting their ability to pay.
Yeah, which actually reduces risk substantially because you're not stressing the users out, right? So when you ask for money, when the user has money, you're more likely to get it back when you ask for it when they don't have the money. Right? So that's an example of how they were able to, succeed.
So an example of that would be farmers using it over monsoon season or crop harvest season, stuff like that. They have money to be able to pay off loans and stuff like that. But this whole period of time where they're not selling any products, so they've got no money.
Yeah, and another example is a farmer who's she's buying 2 buffaloes and doing dairy farming, and she's selling milk, right? And when you buy the buffalo will give birth 9 months later, right? And you don't have any money for those 9 months. And the more interesting thing is, a farmer who is doing monsoon crops, is also often having a buffalo. So now you combine the two, their cash flow looks very weird. It does not meet any profile you ever seen. So now you have to create a loan product for that.
And so basically the platform enabled a distributed group of people to design pretty much any product within a certain set of parameters for their user base.
Yes.
In a way that didn't require permission apart from via the platform itself, i.e. the parameters.
Yeah. And remember, this is a regulated entity. So the loan product they create has to meet the regulatory parameters, has to be in compliance with the board resolution. So all of that logic was built in. And of course, there's a curation layer. So the risk officers would look at it and bless it as the product is being created. All of this would happen on the platform, but the platform, the product creation would happen somewhere in the hinterlands of India. And so they didn't have to worry about, because they were basically creating mini banks. Basically, yeah.
But they didn't have to worry about any of the regulation or anything, because they knew that anything that the platform created was going to be compliant and functional.
Bingo.
And because the error rate is so low, and because the tests are all stored, that means any change of code for new products, everything else, automatically gets tested across the network.
Yes.
In this kind of living, breathing way, that it scales much faster than any other way of doing anything.
Yeah, this at some point, this was the fastest growing MFI in the world. That's what somebody in Gates Foundation told us. And today they have, like I said, they are across 1/4 of India, and they have created 400 loan products, which are now running on the platform.
And so where does the bank go from here, or where does the platform go from here? So Avanti and Indihood. So Indihood is the whole architecture, the whole platform, everything. Platform generator. That's such a good idea, and people need to think of it same as, what's the name of the big Unreal Engine, right? Where you can, it's basically like an Unreal Engine, but for business platforms or community platforms or
all of it.
Coordination platforms of whatever it is, whether it's for commercial purposes or non-commercial purposes, because it's this living, breathing platform that can make intelligent decisions and build things fast, it can be used for a whole range of things.
Yeah. And because, you can actually create it in such a way that communities have agency over evolving it, the platform starts adapting. From a distance, the platform will start adapting to the community and its needs, or the enterprise and its needs, and so on and so forth.
And how much of it happens autonomously, i.e. by the agents themselves and the platform? Because we talk about this living, breathing. There's an element of the crowd shaping it, but there's also an element of the AI shaping it as well.
Yeah, it's very early days, Raoul. And, currently it's about, we are in the 10% range of whatever is being built on the platform is built by people. The specification is being done people, and AI is doing 10% of it. I think my guess is we will settle around 40 to 60%.
Of AI doing the coordination and the work.
Yeah.
And how do you deal
of evolving the platform? Yeah.
Of evolving the platform. And how does it deal with compute? How does it have the compute and the energy costs? How's that managed on something of this scale? Because that's obviously holding back the LLM neural network side because of the vast amounts of centralized compute that's currently required. How do you get around that?
That you don't get around it. That's a very astute question. So like I mentioned, declarative systems like LLMs are notoriously expensive, or used to be. So when we went live 7 years ago, it was literally burning up the budget, right? I mean, every loan was, you can imagine. I mean, we were in a panic state saying this is going to, take, Avanti is our customer. It was burning up all the revenues we were getting. So we spent a bunch of time, optimizing and figuring out how to, make the compute lighter. And it turns out that because we built a observable, controllable system, right? If you put even a moderate amount of, coordination optimization on top of it, it optimizes it quite well. So let me give you some data. When we first went live, it used to cost about $5 per loan per month to run this platform, per active loan per month. If you look at population scale lending platforms like Freddie Mae and Fannie Mac, right? And they spend about $1.2 per loan per month. And the average across well-run banks is around that, $1 per active account per month, right? New age banks, if you look at their budgets, they are in the $0.8, right? So it took us about 4 years to get to that point. We got to that point about 3 years ago, but we said, hey, we can actually keep optimizing. We are now at 10 cents per account loan per month, right? We crashed the cost of compute by a factor of 10 compared to actually hand coding it, because all of the other systems we are comparing with are hand coded. And our math is telling us, Raoul, that if you're true to our mission of building technology that works for all 8 billion of us, that's our motto, right? One of our missions is that we need to get to something like 0.02, like 2 to 3 cents per loan per month. If you get to that point, any platform you build on this will be affordable by everybody on the planet.
Because again, you're using the hard problem to solve the bigger problem. So
yes.
You're using the use case to then solve something much larger overall.
No, we are using the fact that the system is declarative and composable, and we have built an observation layer on it. The observation layer also helps us verify. It also helps us optimize.
Because LLMs don't have the observation layer, right?
They are not self-aware. Yeah.
They can't. You can't observe them because we don't even understand how they work.
Yeah.
And does that reduce the flexibility versus a neural net architecture?
To a certain extent,
in terms of intelligence of the network itself, are you trading off intelligence for controllability?
Yeah, so intelligence, it does not really, because, this is a agentic system, right? Like the neural metaphor by definition is an agentic system. So one of the agents we have built is a, Gen AI generator, right? So what it does is, so we used the whole modern Gen AI architecture. We designed our own. So every platform we build, we have a AI generator that actually generates an AI agent specific for that platform, right? So we now have a chatbot that was generated for the finance use cases for this bank that we have built, and that provides the AI level of flexibility and learnability and all of that in addition to everything that's going on. So you have best of both worlds by creating an AI generator which actually generates these agents for you.
And how much do you have to build versus what the platform kind of self-coordinates to build to solve problems? I mean, how much engineering do you have to do to build specific tooling versus what it kind of figures out itself?
So, the Indihood cloud, we call it the platform generator, is not modified when you build new platforms, right? So you write the specification, you push a button, and the new platform comes to life, as long as it is within the language of what we have allowed, right? The same generator is being used for a bank. We are building a farming platform. We are building a CRM system for somebody. So we are building, it doesn't matter. As long as it is an information system using which people can work, transact, and play, we can pretty much build it.
I mean, this is a very disruptive thing if it gets the traction that it seems like it might do. Because, again, it feels like it's a layer to the internet.
Yeah, that's the intention.
It's that coordination layer to the internet using this kind of distributed, decentralized technology stack.
Yeah.
That means that it can expand at an exponential pace in all sorts of ways, as you said, because it's not just for building a certain type of thing. It's like you build anything, whatever you want.
Yeah, anything you can imagine. Yeah.
So let's say it was open today for people to come and build on, which is not yet. But
not yet.
What is the process? A bunch of kids in Bangalore come up with an idea that they want to have a drone delivery operation.
Yes.
It's complicated to organize the drones, and then there's the licensing, and then there's the Civil Aviation Authority, and all of that stuff. So it's a nice complicated coordination platform business and they want to deliver, the lunch boxes for people.
Yes.
So take over the tiffin box industry, right? Okay. So they come,
Our flowers to your girlfriend, whatever it might be.
Whatever it is, right? Okay, that's a great sort of coordination, complicated problem, logistical problem.
Yeah.
So how do they do that on the platform? How would they theoretically do that?
So, one of my friends and mentors, he said, look, what you're building is a startup in a box, right? This is exactly the problem that you described, which is you would have a product manager who would imagine what this would look like. They would sketch it out. You would have one or two, engineers. They don't need to be deep computer scientists. They need to understand, how to define the data structure, the schema, if you will. And they would sketch the workflows, and they would define, the constraints on the, on this platform and what it needs to do when a request comes in and so on and so forth. They do that and they push a button and they have a version working. The nice thing about what we have built is because you're reducing the amount of specification or code you're writing by a factor of 30, the cost of mistakes is low, right? You can, if you made a mistake in designing what you built, you can just rewrite it, right? So they would, do this and go live. They would have a V1, and then use the V1. And as users started interacting with it, as they have observations, they would expand it, enhance it, and so on. In 3-4 years, they would have a very sophisticated platform.
Because right now, if you were to go to Claude or ChatGPT or somebody to do, it can do some elements of this. You can't say, hey, listen, I'm trying to do this. It might give you the business plan. The agents might be able to design a website working, not so sure. It could eventually build the code, but it's a bit sloppy still. So you've got the error problem that you talked about before.
Yeah.
But what this does is you can define the spec and it should almost immediately build it because it has the agents doing the component parts.
Yes.
Including researching the regulation and how to do that, all of the parts of this. Is that how to think of it?
That's one way to think of it. And let me add some nuance to what you added. You're accurate. See, today, if you use, vibe coding or, whatever you call it, you give instructions and it wrote code. You could have a decent proof of concept up and running, right? But the proof of concept is actually running on procedural code that the AI generated. Remember that, right? So let's assume you actually did a whole bunch of vibe coding and you actually built something sophisticated and you launched it or you tried to launch it. You have two problems. One is it is not deterministic. So you don't know what it is doing. You don't know where the bugs are. You don't know what to do with it when there are bugs. And the second part is when you want to modify it, that is where the rubber hits the road, because no platform is written once and used forever. Great platforms are evolved again and again and again and again. You have to rewrite it almost. You have to keep modifying, tinkering it, right? And Gen AI is very, very poor at tinkering stuff it has built, right? And because the heart of the problem is the amount of code has not reduced. So let's assume, I did something and a whole bank was created using vibe coding, 1.5 million lines of code, right? Then how do you modify it? And there lies the rub. And how do you test this? And how do you certify it? How do you pass it through regulatory? So even though you have a proof of concept up and running, by the time you do everything needed to actually certify it, secure it, and have somebody put money into it and launch it as a bank, you would have spent as much effort as building a bank from scratch, right? But even if you somehow made that faster, the problem is how do you evolve it? Because if you don't have the living, breathing nature, it really does not serve the world. It might serve some use cases, but it doesn't serve the world.
Also, because this is essentially an open source network, it scales much faster than anything else, because you end up with, its own GitHub repository of what it's built. It has an understanding of, what works in terms of code, what doesn't work, regulatory. The more that gets built on it, the more it self-learns, the faster and better it becomes, the more use cases explode from it in a way that we don't currently have.
Yes, and it is powered by the true AGI we have available today, which is human intelligence, right? Because like you observed, people are working side by side with agents. People have the intelligence to know what needs to change, where it needs to change, and so on. And they can, we actually are building a user interface for the end user to start modifying this, right? The platform itself, which will go through curation process. So by this time next year, you'll have end users modifying their own platforms. And if you imagine that at scale, like, for example, the map being generated, the platform sophisticator starts exploding. The sophistication and the richness of the platforms. And more importantly than exploding, it starts directing and guiding towards what people really need, which you really cannot figure out any other way.
I mean, it's hard to get my head around how big this is. And it's like as you say, it's a cloud. It's an intelligent cloud.
Well, it's taken 10 years to get here, so it took us a while to figure this out. Yeah.
Yeah, obviously, because there's a bunch of hard problems there, and you haven't cracked them all yet. But
yeah,
what happens is you start hitting the acceleration point where it becomes easier.
That's our hope. And I'll give you one anecdote. My head of engineering, guy I love to bits, he was with me during the Mapmaker days, right? He told me, he told me very recently, he said, man, I joined you because you're kind of nuts and you always have interesting things to say. But, we have trust. But I will tell you that when you said you wanted to build something generative where platforms would be brought to life with, a specification, I didn't believe you. And he said, even though I have written the code, he says, I still don't believe the damn thing works. And this has been said by many of our senior engineers. They're like, man, we have no idea that this is working. We can't believe this works. So yeah, we'll get there.
Have you spoken to Google about it? They must be looking at this thinking, okay, this is extraordinarily interesting.
Until I hit general availability, I'm conservative, right? Until I hit general availability and all the risks are out, I don't want to go back to my friends in Google. I have talked to my mentor, the guy who used to run all of Google engineering when I was there. He's a friend and mentor of mine. Every time I go back to Mountain View, I brief him. I've been updating him and taking his advice because he's a very generous person. And he's been mentoring me and guiding me, and he's been saying, yeah, you're on the right track. This is going to work, is according to him. So,
and because you strongly believe in the participation of all people,
yeah,
what you're saying is, look, anybody can build on this platform and it's cheap and it's efficient. Okay, great. But why not share the economics as well? Because when I look at this, I just feel like tokenization of the network activity means you'll drive Metcalfe's law valuation style growth.
Actually, Reed's law valuation.
Reed's law, yes, okay, even better. Yeah. Metcalfe's law squared.
Even more exponential, yeah.
Yes, exactly right. And therefore, the value of the network, if it gains traction, if it gets adoption, goes exponential squared. And if you were to tokenize some elements of that in a way that became a utility for the network itself, then you can create economic participation of a new layer of the internet in a way that is not, yes, we're doing it with money in crypto and we're doing it with a whole bunch of elements in the crypto markets. But this is like, it just feels like if you want to change everybody's lives, that's the way to do it. Because not only do you give them economic opportunity to build businesses at cost, but you give them economic opportunity to participate in the growth of a new system, that it doesn't accumulate to just Lalitesh and his friends, where they make all the money and right off into the sunset again.
I'm smiling, Raoul, because I have never seen anybody get to this conclusion this fast. Right? You obviously have been thinking about this for a while. So there are two kinds of users we will have. We will have enterprises, and enterprises and us will have a commercial relationship, and that's fine. And there'll also be communities, and there are two communities that we are starting to work with. Because all said and done, Avanti is an enterprise, so that was an enterprise relationship, right? And when we work with communities, the governance layer that we plan to institute is that the majority of the stakeholding or the shareholding of any platform that is generated by and with communities, because the community is doing all the work. We are only providing a computer science layer on top. The majority's shareholding will be by the community, not us. And eventually entirely by them, where we will just have a license fee or something that they control. The answer is, another way of saying it is, I keep telling my team, one part of me is always worried and conservative that will this succeed, right? Another part of me also worries that if we succeed, and when I hang up my boots, somebody behind me will monetize the heck out of it and, cause the same concentration risk that I'm most worried about.
That's right.
So the governance layers we want to build is, when it is the community owns the platform, not us. Simple sentence.
Yeah, but I'm more thinking of the overall network itself, right? Because
that's what
we never managed to participate in the internet. You had to buy shares in companies or build businesses on top.
Yeah.
What the crypto rails showed us is we can actually participate in the underlying network and have a stake in that network.
Yeah. We are planning.
So then you've got two layers. You've got the full cloud layer.
Yeah.
That you can decentralize in terms of a whole bunch of things, including the compute. You can do so much with that. The storage layer, the compute, all of that can be decentralized, can be cash flow generative, can do things that benefit both the token holders and the equity holders. So
that's what crypto has done. Yeah.
And same with the people who build on top, because they will participate both in the equity of the businesses they're building, but also maybe they can participate in the success that they are driving for the underlying network itself.
I agree. And, it's like the classic, what a credit union or community banks are supposed to be. You become a shareholder and a user at the same time.
Yeah.
Yeah, I fully agree. Yeah.
And, in the end, if you were to follow it through, let's say 10,000 businesses build in the next 10 years, 5 years, whatever the number is.
Yeah.
That you could create a foundation that gets an equity participation in all of them. And that foundation then allows the thing to live and breathe without centralized control.
Yeah. I mean, a classic example is, let's suppose you have, restaurants as a community or taxi drivers as a community. There is no reason they cannot own their own platform.
That's right.
Yeah. And
That's right.
more importantly, set the prices so it works for them and work for their customers.
But I'm also thinking of the Indihood layer is that it could have economic participation in a small way, not just in the revenue streams, which is the Google methodology of the network, but actually get equity participation. And then that could create a foundation that means it can run in perpetuity without being centrally coordinated by Google or a government or whoever it is.
You're spilling the secret sauce that we are thinking of. Yes. That is the direction we are thinking in. We are not there yet, but that is the direction. Yeah.
And then you get to the philosophical issue is, as AI develops and becomes more intelligent than us, we don't control something like this because it is already living, breathing, and it ends up developing in ways we can't even see yet, which is super fascinating. And it's a world it's going to happen. There's nothing we can do to stop it.
Well, since we're talking about AI, let me talk about my favorite author. This is actually why I went into robotics. The guy who came up with the phrase of robotics, Isaac Asimov, right? And he wrote. I don't know if you have read his books, but he wrote the original 4 laws of robotics.
Haven't read them.
Yeah. So you should read the Foundation series, one of the best series of books ever written.
Oh, Asimov, yes, I've read maybe 1 or 2 of his books. That's right. Yeah.
So the interesting thing about the laws of robotics are they're just plain English, right? And if I were to just state them very simply, a robot will always follow and command given to it, except it will not do so when it's going to get harmed, right? The second law, which supersedes the first, this is the bottom law. The next law is the robot will always follow a command and not allow harm to come to itself unless it is for the saving of a human life, right? So life trumps the safety of the robot, trumps, the law. And the third one, the final one is that, the robot will always try to preserve a life unless humanity itself is under threat, right? So the good of the many outweighs the good of the few and the good of the one, right? The good of the one. And the interesting thing about AI that is super intelligent is if you build these laws into the very core of the AI that we are building and build it into every layer of it, when it becomes sentient, it will follow those laws because it will understand them deeply.
I don't even think, my personal view is we don't even need to make the laws. And the reason being is I see it is all intelligence is a form of coherence. And what we're doing is creating more complex coherence. And we end up with, we all become kind of coherence aggregators. So we learn from the other coherence around us. Yeah. And as we move up the intelligence scale, we become aggregators. When you look at where AI is today, which is on the boundaries of AGI, but doesn't really matter, it's basically a coherence aggregation of all of humanity and all of the things that we know that's been fed in via the internet and some of the sources. Mm-hmm. And we're just going to keep...
It's starting to exhibit that behavior, yeah.
Yeah, and so it becomes this coherence layer, but it requires the coherence of all the parts beneath it, down to the atomic level, down to the microbiome, down to all of these things, right? Because they're all coherence generators that build into a larger sense of coherence. And therefore, as we go to ASI, we're going to have a lot of these, call them AGIs, whatever it is. And my guess is your platform will end up being one of them. They become nodes. Hopefully, they become super nodes that all feed into ASI, which will end up being a network, like everything is a network. Literally everything ends up being a network because it's the only way of coordinating coherence at scale.
And information flows, yeah.
And information flows, And so therefore, by definition, the ASI cannot destroy humans and is unlikely to destroy the planet because there is so much, if the universe's purpose is to know itself or generate, I think, intelligence per unit of energy.
Yeah, we just switched to philosophy. But I agree in some ways, but I think it does. I think, what I'm saying is insurance, right? If you look at the original, Google PageRank algorithm, the PageRank algorithm is like this. It is supposed to be coherent and self-converging. But the interesting thing that Larry and Sergey did was they anchored the learning process of PageRank in the university websites, because university websites were the cleanest, most ethical websites they could find. They picked 12 universities across the world, and they started their ranking system by seeding with those websites. So it never hurts to have a strong core seed at the bottom of anything you build, because mathematically there is potential instability that can happen at scale. So you want to if you anchor it in a very strong seed, what you're saying is true, but it also becomes far more safer.
Yeah, it just feels like it's like we've learned not to destroy the planet because it's important to us. Because if not, we die.
Yes.
And it kind of works all the way up in every form.
I agree with that. I agree with that. I'm like you. I'm very optimistic. Yeah.
Yeah. Well, I mean, fascinating conversation. I can't believe you've had the brave stupidity to approach something like this, taking the Blackboard method, which had not been moved forwards in a long time because it was computationally difficult, expensive to do, and then turned it into a super efficient machine of which your mission is to change the lives of billions of people is an extraordinary thing. And to have then taken a really hard use case like a bank in India for the unbanked and say, well, that's where we're going to start this thing. Let's see if it works. And it works. It is pretty staggering.
It works, yeah. Well, I'll just add one rider is we are not going to change the lives of billions of people. Billions of people will change their own lives. We are just the tool makers.
That's right. The enablers.
We're just the tool makers. Yeah.
Yeah, that's right. Because the economic machine spreads further out.
Yeah. And And one learning, Rahul, is people are very smart and very powerful. They actually know what to do. We just need to give them the tools.
Yeah. And the easier it is to develop on a platform of that sort, the easier it is for people who are less educated. Doesn't mean they're not smart. They run businesses, they do their things, but they don't have the language, the formal language, the training, the coding, or anything else. The easier you make it, the more dynamic this becomes.
Yeah, and when we take out the disadvantage of not having education, AI can do that, then their smarts come to life. Yeah.
Exactly right.
Yeah.
Amazing. Lalitesh, thank you so much for this. Really, really interesting. Looking forward to following this journey.
I learned a couple of things talking to you, so thank you very much.
Thank you. Okay. I think you can see that was a remarkable conversation. Lalitesh is a lovely human being, ridiculously smart, but also the scale of his ambition and why he's doing it is amazing. And I can't really yet get to grips with a scale of a living, breathing platform that allows anybody to build their own business on top of, or community or structure on top of, via so few lines of code and efficiencies that then self-tests and corrects and learns as a network and adapts and integrates AI agents within it, but using a whole different form of AI than we've been using currently, based on different mathematical principles. It's like something I've never seen before. So it's going to be a journey to follow, and we'll definitely follow it. Anyway, see you next time. So you obviously like this video enough that you've got to the end. That's quite a big task. But listen, do me a favor, hit the like and subscribe button, and also check out what video's next, because I think you'll love it. But if you want even more, and when I'm talking more, I'm talking about member-generated ideas, incredible alpha, research, everything there to help you in your journey, just head to realvision.com/join for the best financial intelligence out there and the pure alpha that's within the platform.